Hello, class. We're on lesson number 9. We're at the end of chapter 1, and we're going to go over what's called the distributive rule. And the distributive rule is very, very important. We're going to be using the distributive rule. Again, I like to use that term, the rest of our math lives. So it's very important that we understand how to use the distributive rule, what we're supposed to do with the distributive rule. And a lot of this goes into our previous lesson when we're talking about parentheses. And but let's turn over here to page 53. And the oldest game in the world may be the game of Go. It originated in China and is thought to have been played as long ago as the 24th century BC. Go is played with black and white stones on a square board. The object is to capture more territory than the other player while losing as few stones as possible in doing so. The photographer above shows how the board might look at the end of the game. Although the way in which the stones are arranged on the board makes them difficult to count, the stones in the pattern below are easy to count. So we take a look at the one above, very hard to count. Look at the one here below, it's easy to count. Well, two ways to count them illustrate a simple but useful pattern called the distributive rule. One way is to multiply the sum of the numbers of black and white stones in one row, 6 plus 4, by the number of rows, 8. So if we look over here, we would have 8. I'm going to write this up on the board. Times 6 plus 4. Okay? And we know that if we did our parentheses first, we would have 8 times 10, and we'd know that would yield 80. Now, the other way to multiply each of these numbers, 6 and 4 by 8, and well, actually to multiply each 6 and 4 by 8 and then add the result. So we can turn around and say 8 times 6. Now notice I'm using the parentheses. They use it there. We could have gone with simply 8 with the dot, but we're going to keep the parentheses here. It's good that we use it. We're using numbers now, but later on we're going to end up using expressions that are a little more complex. So let's get familiar, let's get comfortable with the parentheses. So we're going to say 8 times 6, and we're going to add that to 8 times 4. So we can see that the parentheses have been distributed. Let's go to say to the 8. We're going to distribute the components within the parentheses, which are being added to 8. So that's why we call it the distributive rule. We're distributing, actually, let's say we want to look at the other way, we're distributing the 8 to the 6 and then the 8 to the 4. So when we go ahead and we do our math here, well, we end up with 48. Let's go ahead and write across, plus 32, and that's going to be equal to 80. Okay, so we got the same result, simply we took a different approach to this. Now, comparing the first way to the second, we see that 8, I'm just going to take the first two parts of these equations or these problems, and we're just going to put them together now. That 8 times parentheses 6 plus 4 and parentheses is equal to 8 times 6. And again, the parentheses there, we can say 8 times parentheses 6 and parentheses, technically speaking. But really, these are just two numbers that are being added. 8 times 6 plus 8 times 4. Okay, and this pattern is true for any set of 3 numbers. So now we're going to introduce a few other letters so that we can teach you the distributive rule. And we're going to use these letters simply as a form. Okay, it's a form. Sort of like if I gave you you wanted to go hunting. I don't know if there are any hunters out there, but if you wanted to go hunting and you say, well, I want to go hunting for deer, but I've never seen a deer. So I would show you a picture of a deer, right? Which means you can then go out into the forest and look for an animal that looks like that. Is it the exact same one? No, it's just a form. Kind of shows you what they look like. So this is, we're going to use a form here, and we're going to use the letters, top of page 54, that the distributive rule for addition for any three numbers A, B, and C. Okay, say, well, Mr. Cartagena, A, B, and C are not numbers. Well, they are variables, or in this case, we're just going to use letters that represent numbers. What could A be? Well, A could be 4, and B could be 3, and C could be 2. And it could very well be that A is 2, and B is 4, and C is 3. So we're just using this to show you a form. Okay. If we were going to refer back to that deer, we would see, well, it has legs. Well, you know what a leg is, right? I mean, obviously it's different from animal to animal, but you would have 4 legs on a deer. Now, if you went out into the forest and you saw something walking around with 2 legs, you'd know that's not a deer. And certainly if it's walking around with 2 legs, it might actually be a human being, so you better not shoot at that. But we're going to use these as forms, and we're going to represent A, B, and C in the distributive rule here as A times B plus C is equal to A times B plus A times C. Now it's similar to what we were doing over here, right? Here's the A in this problem, and here's the B, and here's the C. You see how this is a form, okay? Now, what we did here was we added them together, but we're going to go down here and take a look at this example here. A times parentheses B plus C, right? So let's go ahead and do that. And, well, what was A? Well, A was 8, right? And B is 6, and C is 4. So these letters are representing these these 3 numbers that are here. So if we're going to put them in the same order, well, we are told that A times parentheses B plus C is equal to A times B. Well, what's A times B? Well, A times B would be A times B here, which would be 8 times 6. So you see that worked out. And we have A times C, which would be 8 times 4. So this is the application of the distributive rule in the example. Now, when we see A times parentheses B plus C end parentheses is equal to AB plus AC, we're being given an example or a form that we can apply. And it will get much more complex further down, but we should feel comfortable understanding that when we're using the distributive rule, we're simply multiplying each of the components, okay? And I like to use this as an illustration. Okay, we're just multiplying A times B, AB, plus, we have a plus sign here, A times C. Now, what if we were subtracting, okay? All right, let's just finish reading here. Notice that this rule is about a relationship between multiplication and addition. Sometimes it is stated by simply saying that multiplication distributes over addition, okay? But let's go ahead now try this with subtraction. Well, we have the rule here, and it's going to look very similar. We have A times parentheses B minus C end parentheses. Well, what would that be equal to? Well, we're going to go ahead and distribute again. A times B, but now we're subtracting A minus, or excuse me, A times C. So it'll be minus A times C. So A times parentheses B minus C end parentheses, that's this side, is equal to AB minus AC. Similarly as we had here an addition. Okay, because the product of two numbers does not depend on the order of the numbers, the two distributive rules can also be rewritten with the numbers in each product interchange. Okay, so let's take a look. We have here A times parentheses B plus C is equal to AB plus AC. And A times parentheses B minus C and parentheses is equal to AB minus AC. Now, we can turn around and say BC times A. Now this is going to get a little bit tricky, but just follow. B plus C, and this is in parentheses, so we have parentheses B plus C and parentheses times A is equal to BA plus CA. Okay. Now, this is really no different than what we were doing over here. It's just because we said that the product of two numbers does not depend on its order. Now, let's go ahead and write the second one. We have B minus C times A, and that would be equal to BA minus CA. Now, we know that when we multiply two things, let me just give you the perfect example of 2 times 4. What's that equal to? That's equal to 8. And what is 4 times 2? That is equal to 8. Now, I use this as an example to show you that when we multiply, the order does not matter. If we start looking at the addition and subtraction going on, we might get a little confused. All we did was we simply changed the order. If you see here that this is B plus C times A is the same as A times B plus C, okay? And the result was B times A, which is the same as A times B, plus C times A, which is the same as A times C. So let's not get too confused. These two things are identical. We're just simply playing around with the order because in multiplication it doesn't matter. As I illustrated over here, that 2 times 4 is the same as 4 times 2. All right? So just keep in mind that sometimes you'll have a number, or maybe because of the structure of the problem, things may be in different order. I would tend to take a problem like this and maybe move the letter A to this side, okay? And it would look very much like this one because really we're not thinking so much in these terms. It's just a matter of that we're kind of showing you the pattern and the fundamental principle here. We're not trying to confuse you, but if you put on your thinking caps, you remember that 2 times 4 is the same as 4 times 2 means I can move things that are being multiplied. And as you can see, the results of these two would be the same. Okay, the distributive rules are the most fundamental patterns of algebra. And we must understand this, and it's very important that you master your distributive rule. Again, I will challenge you throughout the year to see it in different ways. Let me clear the board here so we can go ahead and just do some of these samples. Okay, I like a nice clean board. And let's go ahead and get my pen back, and let's start off with the example we have here. Use the distributive rule to write the product 10 times parentheses x plus 2 n parentheses as a sum. They want it as a sum. So in other words, they want to see an addition as a sum in there. So what does that mean? Well, let's go ahead and write. We have 10 times parentheses x plus 2. End parentheses. Well, we can multiply 10 times x, right? And then we can add that to 10 times 2. Well, what do we do here? We followed the same pattern. We distributed 10 times x, 10 times 2. We're adding them. And what do we get when we add those two? Well, we have 10x plus 20. And that is our answer because we're showing it as a sum. Okay? Always remember what they're asking for. If you don't follow, you'll end up giving an answer, though, that may not necessarily be incorrect. It would be incorrect if that's not what they're asking for. They're asking for a sum. Now, example number 2, use the distributive rule to write the product. 5 plus x in parentheses. So parentheses, let's write it down, parentheses 5 plus x times, or in parentheses, times y. All right, we show this as a sum. So how would we do this? Well, we would distribute the y. Now we're kind of almost doing it the other way. And as I said, you can put the y over here the same way. But let's go ahead and just multiply. We have 5 times y. We could put the parentheses around here, but we know it's 5 times y. And we're adding that to x times y, which would be xy, okay? Again, we're implying this little dot, or maybe, again, we talked about in the past how we use the x, which we no longer use because it gets confused with the variable x. But we don't have to show those little dots, okay? We just put the letters together and we know that 5y is 5 times y, and xy is x times y, okay? So, and we're showing this as, again, the sum, okay? Now we have one more example here where we have to write the product of x times parentheses x minus 1 end parentheses, and we have to show this as a difference. So what would we have? Well, we would have x times x. We can show it that way. Now, could we write xx? Yeah, I guess we could, but you're going to see that, well, we're going to write x times x as an exponent. All right, you'll see. We're going to say x times 1, because we just distributed x times x minus x times 1. And when we do this little bit of math, let's simplify it. X times x is x squared. Any number times itself is the squaring. Okay, we talked about that in a previous lesson. And x times 1 is simply x, would it not be? And we're showing this now as our answer, which is a difference. Okay, the difference. It's x squared minus x. Okay. All right, so these are the examples that we've been given, and you can go ahead and do your problems.